Welcome back, my geometric minions. All right, so as we talk about this unit over two-dimensional, three-dimensional shapes, we need to talk about the angles of polygons. Now, a little bit of review, but first of all, polygon. Remember, poly means many. Poly means many. Gons means side. So this is literal translation is it's a many-sided figure. So it's a two-dimensional shape that's closed that has many sides. So in order for it to be closed, you look at it and you go, okay, well, what's the smallest polygon we could possibly have? And the answer to that is a three-sided figure, which we call a triangle. So the smallest one would be three sides. The largest, well, it just depends on how many sides you want to draw in it. You could have a Google sides. That would be 100 sides. So you could have a Google gon technically. So as we look at polygons, there are two ways that we kind of classify polygons when we talk about them, and that is that they are either convex or they are concave. And convex and concave, and those two things have to do with the diagonals. Remember, diagonals, these are lines that join non-connected sides, non-adjacent vertices. Whoops, looks like I left a vertex off. So if we look at the first one, if we look at those, all the diagonals are drawn. There's no extra diagonals on that one. So on the next one, if we were to turn around and draw diagonals, we would have to draw the diagonals to this one. We start drawing them to all the sides. We draw this one right here, and we draw these 1, 2, 3 diagonals here to separate it into different triangles, and we look at it. This one over here, if we turn around and draw the diagonals, there's one diagonal there. There's a second one here. For this one, we draw the diagonals. There are 3 diagonals there, so it separates that one into 4 triangles. So when we turn around, we start to draw these diagonals. That determines convex or concave. So it's really easy to tell the difference between them. Convex means that all of the diagonals are inside of the figure. So which ones have diagonals inside the figure that are completely inside? That would be the first one and the last one. So those two are convex. Concave polygons are polygons who has at least one diagonal that passes outside of the figure. So obviously the second one and the third one, those two that have the diagonals outside, those two would be concave. So there's the difference between those as we characterize them, convex and concave. Now the other term that we use sometimes is regular. Regular. Now this has nothing to do with the amount of fiber in the diet of these things. Regular means that all of the sides, all of the angles are exactly the same. So a lot of times we'll focus on regular polygons when we're talking about it. So a regular three-sided polygon we would call, yes, equilateral triangle. So a three-sided polygon is called a triangle. So looking at this thing, the interior, the sum of the interior angles. Well, remember we said before that when we look at them, it's the number of triangles in it times 180. So in the case of this one, and we know that the number of triangles will always be 2 less than the number of sides. So this one here, it's simply 1 times 180. So the sum of the interior angles is 180 degrees. Now, the measure of one interior angle, which is what this next column is, it's what happens when you take the sum of the interior and you divide by the number of sides. So in this case, it would be 60 degrees. Now the exterior is what we find when we take 360 and divide by the number of sides. So if we have 360 and we divide by 3, we get 120 degrees. So let's look at a 4-sided one. What do we call that? Well, it's a quadrilateral. A regular quadrilateral would be a square, obviously. So the sum of the interior angles here, it's going to be number of sides minus 2. So it's 2 times 180. So in this case, it's 360 degrees. Okay, what's the interior? Well, it's 360 degrees divided by 4, so it's 90 degrees. Exterior is going to be 360 degrees divided by 4, so the exterior are 90 as well. Remember, the sum of all the exterior angles equals 360 degrees. So the next one, 5-sided. So if we look at a 5-sided figure, it's going to be number of sides minus 2, so it's 3 times 180. You're starting to get the pattern here. So 3 times 180, so 540 degrees. That's the sum of all of them. So then if we want to find the one interior, it's 540 divided by the number of sides, or the number of sides and the number of angles are the same. So that means it's 108 degrees. Exterior would be 360 divided by 5. So 360 divided by 5. So that means we have 72 degrees is the measure of each exterior angle. So here we go, six-sided. Well, that's going to be 4 times 180. So that means it's 720 degrees. 720 degrees divided by 6 means each interior angle is 120 degrees. We want to find the exterior. It's 360 divided by 6, so that's 60 degrees. Now hopefully you're starting to see that the interior and the exterior, these two things always, these angles are supplementary. So those two together, because they make a linear pair. So they're supplementary. So the two of them will always add up to be 180 degrees. Okay, and I guess by the way, let's go ahead and go back here. We said a four-sided is a quadrilateral. Five-sided, a five-sided polygon is called a pentagon. P-E-N-T-A. Penta means 5. So it is a pentagon. So when you look at those, it's a pentagon. A six-sided, and you will need to know these names, be able to spell them. A six-sided is a hexagon. Hexagon, H-E-X-A-G-O-N, so hexagon. All right, so seven sides. 7 is a heptagon, H-E-P-T-A. So for this one, it is hepta. Hepta is the prefix for this one, so a heptagon. Some of the interior angles, well, it's going to be 7 minus 2, so that's 5 times 180. So 5 times 180 degrees, so that is 900 degrees. Now the fun starts to begin. So if we take 900 and divide it by 7, we get 128.57 degrees. 128.57 degrees. That means the exterior is 360 divided by 7. So it's going to be 51.43 degrees. Yeah, sorry, every time it doesn't always come up with nice even numbers here. Doesn't always deal with natural numbers. So the next one, 8. The prefix for this one is octa, so it's an octagon. Octagon, so it's going to be 6 times 180. And 6 times 180 means we're looking at 1,080 degrees for this one. 1,080 divided by 8 gives us 135 degrees. And whether we go 360 divided by 8 or 135 plus what equals 180, either way we find out that the exterior for an octagon, for a regular octagon, is 45 degrees. Now remember, these interiors are only for regular figures. Now 9, so that is nana. I know it looks like nono, but it's pronounced nana. It's a nonagon. So nonagon, 9-sided. So we take 9 minus 2 is 7. 7 times 180, so 1,260 degrees. Interior would be 1,260 divided by 9, which would give us 140 degrees, which means the exterior has to be 40 degrees. So a 10-sided. Well, 10 is deca, so this is a decagon. Decagon, so this is going to be 8 times 180, so that's 1,440 degrees. That means that one interior would be 144 degrees, and that means the measure of an exterior would be 36 degrees. So that takes us up through 10. So now let's turn around and let's take a look at an 11-sided. Now an 11-sided, well, when you look at these, that's when we start to get the unique things. Really anything over 10, we would simply name it by the number of sides. So this would be an 11gon. We would just use the number 11 for it. Sometimes you'll see unideca for this one because uni meaning one. So you might see unidecagon named for an 11-sided. So when we look at this one, it's going to be 11 minus 2 is 9. 9 times 180 in this case gives us 1,620 degrees. 1620 divided by 11, we're going to get 147.27 degrees. So whether we look at that as supplementary to give us the exterior, or we look at 360 divided by 11, we see that we're going to get 32.73 degrees is our exterior angle for this one. So when we look at this one, this next one, well, 12-sided, this is 1800 degrees, and 1800 divided by 12 means 150 degrees, which means our exterior angle is 30. And this is one we're going to see dodeca in this one. You might see a 12-sided, but dodecagon is usually the name given to this one. Now, a 20-sided, well, this is going to be 18 times 180, so this one is 3,240 degrees. So that means that each interior is 162 degrees, and each exterior is going to be 18 degrees. So this one here, and we would simply call it a 20gon. So the last one is n-sided. Well, what happens if we have n sides? So the sum of the interior, remember we said the formula was n minus 2 times 180. So there's our formula. So how do we find the interior? So, well, that's going to be n minus 2 times 180 divided by n. Well, how do we find the exterior angle? Well, that one's easy. It's simply 360 divided by n. So hopefully that answers all of those, clears up everything for polygons. We know them. Remember, we should be able to characterize them by their diagonals as either convex or concave. You should also know them by name according to the number of sides and be able to find the sum of the interior angles, one interior angle, and one exterior angle for any regular polygon. All right, hope this helps, and we will see you back in class.